All right, let's dive into one of the most fascinating cosmic detective stories happening right now. It's got everything: a mysterious world, some really tantalizing clues, and a prime suspect that could honestly change everything we think we know about our place in the universe.
So meet Proxima b. It's the closest known planet outside of our own solar system. And at first glance, this exoplanet looks, well, it looks unbelievably promising. This is basically our main person of interest in the search for another Earth.
Now, when we say next door, you have to remember we're talking about space. And in space, next door means 4.24 light years away. Yeah, that's over 25 trillion miles. It's a staggering distance for us, but in the grand scheme of the galaxy, it's really just a stone's throw.
And here's where the plot really starts to thicken. The first bits of evidence are just incredibly compelling. It's a rocky world, a little bit bigger than Earth, and, this is the big one, it orbits inside its star's habitable zone. That's the sweet spot, the Goldilocks region where temperatures could be just right for liquid water to exist on the surface.
But, every good detective story has a twist. And the first major clue that this potential paradise might actually be a cosmic death trap, well, it points to some very, very bad weather.
Turns out, the prime suspect here isn't the planet at all. Nope, it's the star it orbits, Proxima Centauri.
See, unlike our calm, pretty predictable sun, Proxima Centauri is a volatile red dwarf with a really violent temper. Get this, in 2019, astronomers watched it unleash a super flare so powerful that it briefly became 14,000 times brighter in ultraviolet light. And this isn't some rare event. We're talking about a constant barrage of sterilizing radiation.
Astronomer Meredith McGregor, who actually led the study on these flares, she put it pretty bluntly. This constant bombardment could just strip away any atmosphere the planet might have and make it basically impossible for life as we know it to ever get a foothold. So, case closed? Well, not quite.
Because the case gets even more complicated when we start digging into the system's history, and it looks like it has a very unsettled past.
This brings up a really fundamental question about the whole star system. You have Proxima Centauri and its bigger siblings, Alpha Centauri A and B. Were they all born together, like a true family? Or was Proxima kind of a cosmic orphan that got captured into this system a long, long time ago?
Now this is what's so interesting. Researchers ran a ton of simulations of the system's orbit, and yeah, most of them show it's stable now. But look at that slice. A solid 17% suggest it could have been captured in the past. That kind of instability, that is not a good recipe for life to develop peacefully.
A chaotic history full of gravitational tugs of war and drama would create an incredibly hostile environment. It's just another major strike against our suspect, suggesting any life on Proxima b would have faced an almost impossible uphill battle from the very beginning.
So we've got a planet with incredible potential that's facing two huge threats, a violent star and a chaotic past. So how in the world do we crack a case like this from 4.24 light years away? Well, with some truly brilliant detective work and some amazing technology.
One of our most powerful tools is a technique called nulling interferometry. Okay, the easiest way to think about it is like creating a perfect, tiny solar eclipse on demand. It's designed to cancel out the blinding glare of the star, which is, literally billions of times brighter than the planet next to it.
So here's how it works, more or less. You get two or more space telescopes to combine their light in a really clever way. This creates a dark spot right where the star is, basically hiding it from view. And that lets the faint little heat glow from the planet itself shine through. By analyzing that faint light, we can hunt for the chemical fingerprints of an atmosphere. Signs of water, carbon dioxide, maybe even ozone.
But looking from far away is one thing. What if we could actually send a detective to the scene of the crime? That is the absolutely audacious goal of the Breakthrough Starshot initiative.
And just to really grasp how revolutionary this is, just look at this comparison. Our Voyager 1 probe, which is screaming through space, would take 74,000 years to get to Proxima b. Breakthrough Starshot is aiming to send tiny little nanocrafts, pushed by powerful lasers from Earth, on a journey that would take only about 20 years. 20! That's interstellar travel within our lifetimes. It's just incredible.
So all of this amazing forensic work, all of this incredible technology, it all brings us to the ultimate question at the heart of this entire cosmic mystery.
You know, for decades, we've basically been shouting into the cosmic darkness. We've sent messages like this one from the Arecibo telescope, and we've been listening so intently for any sign at all that we're not alone out here.
And that's why Proxima b is so important. It's our very first real chance to stop just listening and to start actively investigating a world that really could be like ours. It's our chance to see if the clues pointing towards life can possibly outweigh all the evidence that's stacked against it.
Which brings us right back to that haunting question that the physicist Enrico Fermi asked decades ago. If the universe is just teeming with possibilities for life, then where is everybody? Maybe the complicated, challenging story of Proxima b, with all of its promise and all of its perils, is the beginning of an answer.